everybody, my name is Aiden Eder, and today I'm here to review AP Physics 1 Unit 1 Kinematics for the upcoming AP test in May. So the first thing you should know is the difference between a vector and a scalar. Scalars only have magnitude. They're just a regular number, but they're always positive. So examples of this are like speed, mass, distance. You never hear anybody say that they have negative mass, okay? Vectors are similar to scalars, except they have a direction. So if you're talking about one-dimensionally, this just means that they can be negative or positive. If it's two-dimensional, it's a lot more complicated and you have angles involved. But yeah, so like velocity is just speed, but it can also be negative if you're talking one-dimensionally. So with vectors, you have component vectors. And component vectors are just, if you have a vector in 2D space, you have an x direction right here and a y direction. And you can use trigonometry to find out, like using angles to find out the components, or if you know both of the components, you can use the Pythagorean theorem to find out the full vector length. And it's pretty complicated, and you'll have to use it in later units usually. So then you have displacement, velocity, and acceleration. All of these are very related. Displacement is x, velocity is y, acceleration is a. And you'll see, like in this graph, the slope of this displacement over time graph is the slope of this is just graphed onto here, and the slope of this is graphed onto here, which is why this is a lot more blocky than that, that's a lot more blocky than this. And if you're familiar with calculus, the derivative of position is velocity, the derivative of velocity is acceleration. So then you have center of mass, which is a very important concept. If you have an object in physics in an equation, you're just going to draw it as a dot, and that dot represents the center of mass of the object. And for center of mass, if you have a system with multiple objects, you should know that the center of mass is going to be skewed towards the object with more mass or more weight. So in this case, the center of mass will be closer to the item of 500 pounds compared to the one of 100 pounds. And so then you have the meat of the unit, which is the kinematics equations. And you have 4 here, and you have 4 variables. X, which is position, V, velocity, A for acceleration, and T for time. These 3 are on your physics reference sheet, which you will have on the AP test. This 4th one is not, which means you will have to memorize this if you want to use it. And you'll use them all in different scenarios depending on what variable you're solving for. So then I have an example problem. And in this example, an airplane accelerates down a runway at 3.2 meters per second squared for 32.8 seconds until it finally lifts off the ground. Determine the distance traveled before takeoff. And you can use the second kinematics equation, which is on your reference sheet. So in this one, you just have the kinematics equation, and then you can plug in the numbers. You can assume that the initial velocity is 0 since it doesn't say an initial velocity. You multiply that times the time. This 0 times anything equals 0, so you don't bother with this. And then 0.5 times acceleration times time squared. And it's 0.5 times 3.2 meters per second squared times 32.8 seconds, because those are just these numbers plugged into there for acceleration and time. And then total, you get the position equals 1720 meters, which that answers the question. 1720 meters are traveled before takeoff. And so for the second example problem, you have something a lot more complicated. And this uses 2 equations. If Michael Jordan has a vertical leap of 1.29 meters, then what is his takeoff speed and his hang time? Total time to move upwards to the peak and then return to the ground. And this will become important here. So you use 2 equations for this. The first one you can use is the third kinematics equation, which is on your reference sheet. And this you have here, and you can plug in the numbers. Velocity final, since it's going up to his peak at that moment in time, his velocity is 0. Okay, so you can plug that in there. You're solving for velocity initial, which is when he jumps. You can plug in the acceleration due to gravity, which is constant on Earth, and then you can plug in the displacement that it mentions here. And for that, you can manipulate the equation, and you get velocity initial squared equals 25.28 meters per second, or with the 2 squares, because this is squared. And then you get velocity initial equals 5.03 meters per second, which is his takeoff speed. And then you can use the first equation to find out the second part of the question, and you plug in velocity final 0 for the same reason this is 0, and velocity initial 5.03 meters per second. You got that from this problem. And then for acceleration, you plug in the constant acceleration due to gravity and time, which is what you're solving for. And then you manipulate the equation, you divide both sides by gravity, and you get the time equals 0.513 seconds, which you multiply times 2 because you're looking for the total time he's in the air. So that's 1.03 seconds, and that's his total hang time, which answers the question. Thank you. That's all.